everyone, excuse me, Mrs. Vara here, and this is Unit 13, Section 1. I'm just going to go through a couple examples, probably just 1 and 2. Sorry, my camera is swinging. So if you notice, this is all about graphing, rational functions. So these are the same type of functions that we had in Unit 12, so we're still going to have things that we have to factor in the numerator and the denominator. And the other big thing we're going to find out are points of discontinuity. So I can determine the vertical asymptotes, that's a new vocab for you, and or points of discontinuity. So these are the same restricted values that you found in Unit 12. And then we're going to say I can graph them. Now we'll probably be doing most of this graphing and getting the table of values on our graphing calculator. But before we do that, I want to show you briefly what a vertical asymptote is, and also the other thing we're going to talk about and find are vertical asymptote and holes in a graph. I'm just going to flip this over and just draw a quick example here. So here's my x and y axis. And then I'm going to say for this graph I'm drawing, this is 1, 2, 3. This is going to be a made-up graph. But I'm going to say this is going to be my vertical asymptote. And it's going to be here at x equals 3. So that's 1 and 2. And then I'm also going to put a hole in this graph at x equals 1. So this might be what my made-up graph could look like. I'm going to make this go down a little more. So this is headed towards 0 in this direction, and then it's headed up, but when it gets to that vertical asymptote, it gets close to this line, x equals 3, but it never reaches it. And then a lot of these graphs will have something on the other side also. Sometimes they look like a reflection, sometimes they don't. So this is a vertical asymptote. It's a vertical line that your function, the graph of your function, gets close to but never reaches. So this function that I drew here would never have an x equals 3. This would be the restricted domain, x equals 3. And then this is what a hole looks like. It literally looks like a hole in the graph. And this would be at x equals 1. So we would have our domain, our restricted domain would be x cannot equal x cannot equal positive 1, and x cannot equal 3. So that's what we're going to find, holes and vertical asymptote, the x values where those occur. Alright, you'll see I have a bunch of notes on here already. So the first one is definition of continuity. So here's your official definition: the unbroken or consistent existence or operation of something over a period. Sounds confusing. This is the important thing about a continuous graph, is when you can draw the graph without lifting your pencil. And in advanced math and in calculus, this is the important thing you need to know. Can I draw my graph without lifting my pencil? So if you look at that graph I just drew, this is not continuous because I have to lift my pencil here and here. So this is not a continuous graph. Up until now, just about everything you've looked at has been continuous. Alright, so you should probably pause the video and fill these notes in. And then here it says to find the asymptotes and or holes of a rational function. Remember, rational means a fraction. We look at its denominator. And so we're looking again at those values that make the denominator 0 because we can't have the denominator equal to 0. So just like we did in Unit 12. So this first example says determine the equation of any vertical asymptotes and the values for x for any holes. So we're going to find both in this example. So this is our function. Now I'm going to show you, before you start writing these steps, that I put this function in my calculator. So here it is punched in. If you're putting it in, make sure you put your numerator in parentheses and then divide, and then your denominator in parentheses. So here's my graph. So you can see right here, it looks like I have a vertical asymptote. Now I can't see the holes when I look at the graph, but if I go to table, you'll notice here it says when x is -1, I have an error. So this is a restriction. X cannot equal -1. And then if you look down here, it says when x equals +1, I have an error. So one of these is probably the vertical asymptote. And if I look at the graph, that would probably be the x equals 1 is the vertical asymptote. And then if I look at the table again, I'm guessing after we do our algebra, we'll find we have a hole at -1. So x equals 1 is the vertical asymptote. I think this -1 will be a hole. So here's the steps for doing this. So once again, you're going to want to pause the video and copy these steps. I'm going to work through these steps on this problem. You should probably write smaller when you fill this in your notes because you can see I took most of this space. So I'm going to do the work for this problem down here. So the first one says factor completely. So I want to factor my numerator and my denominator. So I'm going to say this is my step 1. So in the factored form, this function equals 4x minus 3. I'm not going to show the factoring in this video. You guys are experts at it now. That's my factored numerator. This is my factored denominator. So let's just do a quick check here. 4x squared, positive 4x, negative 3x. That gets me x and minus 3. Okay, so this is my factored form. Then it says step 2, find the restricted domain. So this is anything that makes your denominator equal to 0. So this is the same thing you did in Unit 12. If I want to find out what would make my denominator equal to 0, I take both of those factors, set them equal to 0, and solve for x. So here I would minus 1 from both sides, and I would get x equals -1. Here I would add 1 to both sides, and I would get x equals 1. So this is important. We already know that because we looked at our table of values. Now I have to decide which one of these is the vertical asymptote and which one is the hole. And that's what step 3 is. Determine if the restrictions, those are what I found, is an asymptote or a hole. Okay, so if, notice here in our factored form, if you were doing this problem and at this step you were going to simplify, you would say, ooh, x plus 1 and x plus 1, 1 out, right? Those divide to give you 1. So if that happens, if you have factors that 1 out, that tells you that that is a hole in your graph. So the factor that produced the hole is x plus 1, because that's the factor that I 1'd out. So that tells me x equals -1 is my hole. Now this factor is still left on the bottom. This didn't 1 out. So this is always going to be there. So that tells me that is my asymptote. So the asymptote is at x equals 1, and the hole is at x equals -1. And that's why when we looked at that table of values on our calculator, the y values that went with these, we got an error because those are restricted domains. X equals 1 and x equals -1. Okay, so that's what this third part is saying. If the factor of the restriction can be reduced, canceled, you guys like to say, I say 1 out, then that's where your hole is. So factor, top and bottom, find your restricted domain, which always is from your denominator, set the factors in your denominator equal to 0, solve for x, and then go back and see, do any of these factors 1 out? If they do, that's your hole. If they don't, that's your asymptote. So this is, I'll let you guys do that in your own words. Describe a vertical asymptote and describe a hole. And then I am just going to and I recommend you do also, do a small sketch of this graph. You have it in your graphing calculator, but I'm going to say I want to use this information. I know I have a vertical asymptote at 1, so I'm going to say that's x equals 1. And I'm going to draw this vertical line. I usually do my asymptotes dashed. And then I know I have a hole at -1. So now I could do a table of values for this, but we're not going to. We're going to look at our graph. So then we can see our graph crosses the y-axis here. So at -1, I want to put that hole. And then it's going to go down here and approach this vertical asymptote at x equals 1, but never reach it. And then the other side does something like that. Yep, hole at -1, vertical asymptote at 1, and that's what our graph looks like. All right, let's look at one more. So this is example 2. Okay, this one I did not put in my graphing calculator, but I have the table of values. So I will tell you what the table of values are here. So you can get the table of values from your calculator. All right, step 1 on the other page was factor top and bottom. So the numerator can't be factored here, so that's going to stay x minus 1. The denominator factors into x plus 3, x minus 1. So this is step 1. Okay, so now I know something's happening with these two factors. So step 2 is find the restricted domain. So I want to take my denominator, the two factors in my denominator, set them equal to 0 and solve for x. So I'm going to get x equals -3 and x equals 1. So I know these are my restrictions. Now I have to figure out which is a hole and which is a vertical asymptote. So go back up here to your factored form and notice x minus 1 and x minus 1, 1 out. Those divide to give you 1 or cancel, like you guys like to say. So if the factors cancel out, that means that's where my hole is. So my hole is going to be at x equals 1. The other factor that doesn't cancel out, which gives me x equals -3, is going to be my asymptote. So if you put this in your graphing calculator, you would get, here are some of the points. When x is -5, y is -1/2, -4, -1, -2, 1, -1, 1/2, 0, 1/3. So now let's graph this. First thing you want to do is put a vertical line at x equals -3, because that's your vertical asymptote. So this is what we're going to get close to, but never touch. Okay, and then we have a hole at x equals 1. So x equals 1, I didn't get that point here, but I can find out the y value that goes with 1 by plugging 1 into this function here. So I'm going to actually go ahead and do that. When x is 1, f of 1 would be in the numerator. I would get 1 minus 1, which makes me think I'm going to get 0. When x is 1, I get 0. So my hole must be right there, and over 1 up 0. And then if you graph this in your graphing calculator, you would see you're doing something like this. And like this. I'm going to take a quick peek because I did put this on Desmos. And actually, if I look at it on Desmos, I just want to make sure. Yeah, it approaches 0 here, and when x is 1, I'm not at, I'm actually up a little bit. So let's fix this up a little. Sorry about that. This is actually going to be a little bit above, so it's going to do this, and then it's going to approach the x-axis here but never reach it. So that's what it looks like. You can do that in your calculator. So step 1 is always factor, just like it was in Unit 12. Step 2, find your restrictions, and then step 3, figure out if these restrictions are wholes or vertical asymptotes. So because x minus 1 over x minus 1 won out, that gave us our whole. And the x plus 3, that factor stayed, so that gave us our vertical asymptote. Okay, that's all we're going to do in this video. We will do the rest in class tomorrow.